Hello and welcome back to my channel. I'm on a different machine and it's also different software, so I hope you will be patient for a bit and see if this works. And thank you so much for subscribing. Really grateful for all the subscribers. Please like, share and subscribe if you want me to continue as well. Today we are going to talk about concurrency. So as the name suggests, it's talking about things that happen concurrently. So if you think of the analogy of a human body, processes happen all at the same time. So I have all my five senses and I can see, I can breathe, my heart's pounding, I can do all these things, and that's concurrently. Up until the early 2000s, there's only a single core processor. For the older people out there, they remember. Until the early 2000s, most computers had just a single processor. So operating systems would execute a task concurrently by rapidly switching between them, doing a small portion of each before moving on to the next. So there was things like, if I remember correctly, no, don't quote me on this because I was going to say round robin algorithm, but don't quote me on this. So there were things that they do a small portion and then move on to the next one. And so all the tasks would keep processing together. So now we have like things like that we can have a PC to compile a program, send a file to a computer, do all these kind of things all at the same time. And that's Java supporting concurrency. So when we say two tasks are operating in parallel, we mean that they're executing simultaneously, so at the same time. So parallelism is a subset of concurrency, just like the human body. You can do things all together. Then we want to also talk about different things such as threads of execution, so how we do it. So Java supports it. So within Java's language and APIs, you can use already made things. So it supports what's called threads of execution, which is basically a thread has its own method called stack and then the program counter, and allows it to execute concurrently while other threads sharing with the application wide resources such as memory and file handles. And this is called multi-threading. So we have so far Java concurrency, parallelism, threads of execution, and multi-threading. So when we talk about things happening, concurrent programming, then we have, oh, there's my watch. We have things that happen, like, so if you have video and audio over the internet when you're streaming it, the user may want to just wait until the entire audio or video downloads before they start playing the feedback. So if you're on YouTube, which you are now if you're watching it, you might want to wait until it's already streamed, though wait to start it. And to solve this program, then multi-threads can be used. So one to download the audio or the video, and this is later we'll talk about consumers and producers. But remember this for now, consumers and producers. So these activities proceed concurrently. So to avoid all the choppy feedback, it's synchronized. So they share, the producer and consumer threads share memory. Then we can talk a little bit more about concurrency programming. Is a little bit tricky because we're using pre-built classes that the majority already have with the concurrency APIs, such as like blocking queues and these concurrent like linked blocked queue as well. There's another one. But the three other things to remember for synchronized tasks are notify all, and wait. Those three are, like, you'll see in a lot of places as well, especially in Android programming. If you progress from Java to Android as well, you'll see some of that as well. There's other things like lock and conditions that you can set, and you can link to transfer queue and things like that. So the other thing then is to talk about the thread states. So when a thread is in its new state, we have new. Then it goes into runnable. So if it's running, And then you have 4 other states: you waiting, timed waiting, terminated when it's finished, and blocked. So there are the 4 main thread states, as we say. So a new thread is when a new task starts, and it's going into the new state, and then it flicks into the runnable state once it's started. The waiting is waiting for while it waits for another thread to perform a task. So maybe you're waiting. Then a runnable thread can enter a timed waiting for a specific period of time as well. Yeah, you can set up, like, on a side note, if you think of it this way, it's a good way to kind of visualize it. There's the job schedulers that like wait until the other job is done before it starts, or it runs and then finish is blocked by something, which is another thread state, and then another one starts, and then the other one then is like basically goes again if it was in a timed waiting, and so on and so forth. You can kind of imagine standing at traffic lights and one person is waiting, the other person maybe catches before the red man comes, this kind of stuff. So a runnable thread can transition to a time state if it provides an optional wait interval when it's waiting for another task to be performed. So then we have things like sleeping threads as well. So a sleeping thread remains timed waiting state for a designated period of time, after which it returns to the runnable state. So it's timed wait, and then it goes back to the runnable state. Then we've got the blocked state. Something's blocking it. A runnable thread transitions to a blocked state when it attempts to perform a task that it cannot be completed immediately. So it must temporarily wait for the other task to be completed before it starts. So for example, when a thread issues input-output request and the operating system blocks the thread from executing the input-output request until the other output and input request is completed, and then the blocked thread transitions to the runnable state so it can resume execution. A blocked thread can not use a processor even if one is available. So then we have the terminated, which means it's finished, dead state, done. So that is it for today. I'm doing a very short videos in this series of videos. Please provide feedback below. We've covered a little bit of vocabulary with this, and the example will be next week then. So we have our life cycle, so new, runnable. We have our timed wait, waiting, wait, blocked, and terminated. Then we have our synchronized, notify all, and wait. And we are going to use those when it comes to examples as we continue, because concurrency is a little bit tricky. So watch out for that. Everyone, please stay healthy. Thank you for your patience with the videos, and I hope this software and this computer is up to speed. Otherwise, I'll have to change it for next week. But thank you so much for watching, and thanks for subscribing. Stay safe. Bye.